Hey guys, so today we are looking at symmetry in figures, and when we rotate or when we reflect figures, how that symmetry looks inside them. So a couple things you need to know about line symmetry is a figure in the plane has line symmetry if the figure can be mapped onto itself by a reflection in a line. So what that means is pretty much if you would fold something in half and it looks the same on both sides, then it has line symmetry. The line of symmetry is what that line is called. So looking at this figure, we see that it is a rectangle. How many lines of symmetry do you have? How many times or ways could you fold it over itself and it look the same? We fold it in half this way, it would look the same. We fold it in half this way, it would look the same. It would overlap and not have anything hanging off. So this one has two lines of symmetry. A regular pentagon, that regular is key. That tells us that all the sides are the same and all the angles that are the same. So we could fold it in half here, we could fold it in half here, we could fold it in half here, or here, or here. So it looks like a pentagon has 5 lines of symmetry when it is a regular pentagon. Now, this doesn't tell us it's regular. Looks like it's been stretched out a little bit. It looks to me like we probably could still fold it in half this way, but we couldn't do any more than that. So this one would have 1 line of symmetry. And then our butterfly looks like right down the middle has 1 line of symmetry. Okay, so rotational symmetry. A figure in a plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. In rotational symmetry, the center of a figure is called the center of symmetry. So looking at these, it says, does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. One thing to note is if it's a regular figure, we can find the degree measure of the rotations by taking 360 and dividing by the number of sides. So in this case, we have a square. That's a regular quadrilateral. So we could do 360 divided by 4. That is, so yes, it has rotational symmetry. 360 divided by 4 is 90 degrees. We are going to then count by 90 degrees until we hit 180. So 90 degrees, 180 degrees. If it doesn't hit exactly 180, we go to the number just before 180. A regular octagon. So regular means that we can divide it. So yes, we do 360 divided by 8, that would be 45 degrees. So then we're going to count by 45. So 45 is 90. 45 more is 135. 45 more then is 180. And we're finished there. Now a kite, remember, has these measures of congruency, those line lengths, so segment lengths. So if I try to rotate that at all, it's not going to rotate around and match until it gets all the way around 360 degrees. Now this one's a little different. We'll assume that it is same angle measures inside here, but since it's a concave figure, we can't quite treat it the same. But think about if I rotate from here to here. How many points does it have? How many times can I rotate it around? So I count 1, 2, 3, 4, 5, 6, 7, 8 points. So just like that octagon, we're going to be able to say yes. And then it would be 45 degrees, then 90 degrees, then 135 degrees, and then finally 180 degree rotational symmetry. Alright guys, I'll see you in class. If you have questions, please come and see me. Have a great day.